treatments are the ones who get sick. So there's negative sides. They're doing comparison minus case here. So there's a couple things about the way the data is presented here that's useful, just because it contrasts with how we usually do things. And again, there's partially a disciplinary divide on that, but I found this a little confusing when I first saw the table. Basically, this is the difference of minus 17%. The cases are doing worse, and the cases are doing slightly better before. The treatments are doing slightly better before. So in our regression, diff and diff regression specification, and from lecture last time we derived sort of how to get here, equation 2 minus equation 3 from what we had last time. There's the sort of post-difference, diff1, and the pre-difference, diff0, and that gives us this effect of 18%. In other words, once you start experiencing AIDS-related morbidity, there's a drop of about 18% in how much T you can pluck. Now, these guys, when they get sufficiently sick, stop working. So we're not literally observing their productivity when they're most sick. This is their productivity when they're still healthy enough to do some work. And even then, even a year and a half or a year before death, their productivity had fallen off considerably. There's a hand up. Is there a hand up? No. Okay? Now, there's an extension of this that they discuss. Before, they talked about how much you pick per day you pluck. That was your productivity per day. It turns out there's another dimension of productivity that's pretty important here. And in some ways, this ties back to the deworming case. Remember, the deworming case was a big effect on just attendance at school from being sick. You didn't attend as much. These guys' attendance at work, once they started getting sick, declined a lot. And that makes sense. They just couldn't work full work weeks anymore. And when you take into account the drop in productivity from missed days, one day every week or one day every other week, plus the drop in productivity for days they were there, there's actually a drop in total T plucked by these sick workers by about a third. So that's more like the kind of effect I would have thought would have been there. In the last year of life and the period before antiretrovirals, people's health was just declining incredibly rapidly. So their total amount plucked fell 35%. Yep. So they have these, I'll come to that in a couple slides. They have these shifts in type of work. I think this is including production of T plucked, if I'm remembering correctly. Maybe I'm misremembering it. People adjusted by switching jobs. They adjusted by bringing helpers, which we'll talk about, all of which really kind of contaminate the effects that we're going to. Well, maybe I'm misremembering it. This is the number that I pulled, but maybe I missed something in the article. Or maybe this was how much your productivity dropped at T plucking. Maybe I got confused. I'm not sure. Either way, it's obviously a really big effect. So now we have a clicker question. And this is a little bit of an out-of-the-box question, so you may have to think a little bit about it. Think through the following scenario. Think through the possibility that some people in the control group in 2002, when the data collection ends, have not yet been diagnosed with HIV/AIDS. But maybe they will like in a year, or in 6 months, or in 3 monts after the end of the study period. So think through contamination here of the treatment control group. Is that contamination going to lead us to overstate the effect of HIV on productivity, of AIDS-related morbidity, apologies, on productivity, understate the effect of AIDS-related morbidity on productivity? Could the bias conceivably go in either direction, or is it, in these 1 minute, do you not have time to really think through? And I'm going to keep track. I know who answered what. Okay, let's just go another 5 seconds. Okay, so pretty much everybody got the right intuition, or most people got the right intuition, which is it's going to lead us to understate the effect. And this is a finding that comes up in a lot of experiments, and it's related to the intuition we talked about in the deworming case, where this isn't a direct spillover effect. But if for whatever reason we're misclassifying people's treatment, whether due to spillovers or here because we haven't yet diagnosed them, that's going to tend to reduce the differences between the two groups. Because some of the productivity drops we see in the control group, we'll come back to that in the next slide, might be related to the fact that they're entering this early stage of AIDS-related morbidity. So again, the estimates we have at 18% and even at 35% are probably underestimates of the true effect. And so this is the idea. If some controls are ill with HIV/AIDS, it'll be a lower effect because their productivity may already be falling. You can kind of see some of that here. You see, 2 years out, there's kind of this parallel trend, and then you see the big drop among those who are diagnosed as being as having AIDS-related morbidity. But the other guys show a smaller reduction over time. Now, one possibility is some of those guys were a year away from dying of AIDS and hadn't gone to the clinic yet. What are some other possibilities in the declining productivity over these few years? Yeah. It could be weather-related, maybe in a couple of years closer to death. If it's only a short panel, there was a bad crop. What are some other reasons? Mm-hmm. Some people among the comparisons may have been helping the treatments, and that could reduce productivity. So that would be part of the overall negative effect of AIDS-related morbidity on overall productivity for the firm, but it wouldn't only be concentrated among those who are diagnosed with AIDS. What's another one, David? Everybody is getting older. Everybody's getting a few years older here, and in terms of this kind of physical work, people's productivity is going to peak in their 20s and decline. So it's very natural that you would see this kind of decline over time. Yeah. Actually, maybe that's right. Because of the matching between the kind of treatments and the controls, effectively there is some kind of control. So we have to be. Now I forget exactly how they control for seasonality. If they control for sort of month of year across all of the years, or if they also had year controls. If they didn't have year controls, the comment that was made before could still be relevant. If it was just month of year but not year controls, you might still have this year effect. If they had sort of like month by year controls, then that would kind of be soaked up in here. But any other explanations? Yeah.
This is my question actually.
Yeah.
So there have to be HIV infection control.
Yeah.
Wouldn't we be taking effect only to assume AIDS has an effect on productivity? And kind of obvious question.
You're saying that maybe the contamination for whatever reason leads to improved, higher productivity or something, or so conceptually you're saying it could go either way. We're not sure how the bias could. Yeah, for sure. So we would have to have some sense about the likely direction of the effect to understand what's going on. But I think it would be plausible to think that the effect among the controls would sort of be similar to the effects we see among the treatment. So, but that's right. We have to have some notion of the sign of the effect, the direction of the effect, for sure. Yeah. Okay. So this has already come up about helpers, but the helper issue is another reason why these estimates are likely to be lower bounds. So it's either other workers who are helping or family members who are helping, and that's going to tend to improve the productivity of the folks who are sick. So this 18% number, 35% number is almost surely a lower bound for a number of reasons here. Okay, now just stepping back for 1 second, we've been talking about the differences, and is it even I know we showed basically that it looks like there's sort of parallel trends. Is that sort of good enough evidence for you to think that the difference in difference is giving us something meaningful here? Or is there just something different about the folks who become sick with AIDS that would lead them to have a different time pattern of productivity over time? Yeah?
The gender composition was different because you given the group.
So if that isn't sort of adequately controlled for in these matched groups, then if there's differences in the evolution of productivity by gender for whatever reason over time, that could be part of the story. Okay, so that's one possible story. Again, they have data on gender, and they can control for like women's productivity and men's productivity at different ages. So I'm a little less concerned about that. Can you think of things they didn't measure that could be evolving in ways that could lead to this kind of bias? Yeah. Right, so that would be the kind of thing we'd be concerned about. Can anybody think of some kind of behavioral factor, psychological personality factor that could lead to this sort of time-varying productivity, and that might also be correlated with risk of AIDS infection, HIV infection that would turn into AIDS morbidity? I guess that's the story. There's one clear theory we have about what that factor would be. These are the questions you have to ask yourself when you see a diff and diff. Is there something that could lead to a time-varying pattern that somehow would correlate with treatment? In this case, getting sick. Yeah.
Maybe for those healthy people, they are more self-controlled and they learn quickly, so the data experience can help them to gain more productivity a long time.
So maybe there's just something about how risk-taking people are, that people who are taking more risks are more likely to become infected, and people who take more risks just have a different sort of pattern of productivity over time, maybe they put less care into their job. That would be one sort of story. What would the response be given the time plot that we saw that? Or how would the researchers here defend themselves against this plausible, potentially plausible explanation? Yeah. Yeah, I think they would say, look, they look so similar at the beginning. They were trending the same way. We would think if there's this fundamental sort of personality thing, it would sort of reveal itself, unless for some reason that characteristic only kicks in at some point. So after a certain age or with a certain number of years of experience, then their behavior shifts. Like maybe for the first few years you work at the plantation, you're on probation, and then you get a permanent job. And then once you get tenure, you just slack off. Yeah, go ahead. Yeah.
Yeah, I think that's not the case. I think to make argument that it was the age grade work, because people's like prefrontal cortex report that develop different rates of like younger workers might be more risk taking.
Yeah.
But one control for age matches both of them.
Yeah, if we think that age is related to self-control, then controlling for age would help, something like that. Okay, so no other story. I mean, people are typically stumped in the sense that the fact that they look so similar for like a year or two beforehand tends to make us think that maybe they're pretty comparable. But these are the kinds of questions you have to ask yourself if you're going to read a definitive paper or use a definitive method. Yeah. So the question here, just to repeat it for those in the back, was what if people who think they may be at risk of becoming HIV positive or having AIDS are like working extra hard for a year or two once they realize they're at risk? And so in some sense, the comparability between these two groups is sort of inflated or artificial or something and doesn't reflect underlying basic productivity. And then as they become sick, they kind of revert back to their pre-existing behavior. This is where it'd be really nice to have data back 4 years, 5 years, 6 years. I mean, if you could show that 6, 5, 4, 3, 2 years before, they were just exactly parallel, the farther back the data goes, the harder it is to tell those kinds of stories. But that's why, again, more data sort of helps us rule out explanations. Okay, so we've gone through this one measure of impact, and when we talk about Rebecca Thornton's work, which I think we'll probably get to at the beginning of the lecture next time, we may talk about some other dimensions. There is a lot of empirical work out there now trying to document the impact of HIV/AIDS on economic development. There's a series of papers looking at the impact of AIDS-related parental deaths on child orphans left behind that tend to show large impacts on the negative impacts on the orphan's education, for instance, or nutrition. There's a series of papers like the Fox et al. That have come out since then looking at labor productivity, turnover. So there's a kind of well-established micro-literature that on a number of different dimensions, HIV/AIDS could be negatively affecting both current workers and the prospects of the next generation. The next question is this question of why HIV continues to spread. So now that we're really convinced what a big problem is not just the health reasons, which are enough, believe me, to justify intervention, but on top of the health reasons, these economic reasons and impacts, why is it continuing to spread? Why are there still millions of infections in settings where maybe 8, 10, 15% of the population is infected? Why isn't everybody practicing safe sex? So let's turn to some of the explanations. The immediate explanation people come to are the sort of stock response. Well, maybe people don't understand the problem. Maybe there's a lack of information. We talked about this in the last lecture that all the survey evidence for many years now indicates that people in throughout sub-Saharan Africa know that HIV is spread through unprotected sex. That's a well-known issue. It's not a mystery. It's not like 1984 or 1985 where no one knew what was going on with the epidemic. So what else could it be? So let's talk through a model, and this very simple model is going to allow us to illustrate 3 or 4 different mechanisms and channels, and also maybe shed light on the potential effectiveness of different interventions to stem the spread of HIV. And what's nice about the model is it lets us, in the same framework, compare these channels. So models in economics are basically thought experiments. We basically are going to make a bunch of assumptions about individuals here. There's going to be individual behavior, what their options are, what their choice set is, and what constraints they face, and then they're going to make decisions. So that's what we're going to do. So imagine there's 2 periods in life, simplifying, youth and old age. And the way it works is in people's youth, they have to make a choice about whether or not they're going to have unsafe sex. And then they live with the consequences of that in old age. In particular, their mortality risk is going to be affected by that decision. So that's going to be the trade-off here. Do you want to have whatever benefits there are from unsafe sex in your youth, and you're trading that off against the risk of morbidity and here mortality in particular? Now, this isn't really like a one-time decision on one night. It's really more, because the chance of infection from any one particular sex act or engaging in sexual intercourse one time, the chances of transmission are so low, much less than 1%. Think of this more as having a certain approach to how many partners you have, how much unprotected sex you have, maybe over the course of a few years. So it's really more, generally what your sex life is like, and are you going to be someone who has, lots of unsafe sex or not? The reality is there's a continuum, right? You can have unsafe sex once, twice, 3 times, 4 times, etc. And we're not going to model that decision in a very continuous way. We're just going to, for simplicity, say you either are someone who has unsafe sex a lot or you don't have unsafe sex. And that's just going to simplify the intuition, but you can extend all of this to sort of a decision over every single chance you have to have unsafe sex. This is going to simplify things. Again, the main cost you pay in this model for engaging in unsafe sex is it affects your mortality risk. If you are HIV negative, you have a likelihood of living to old age, which is denoted by P, which is an element of 0 to 1, meaning you have a chance somewhere between 0 and 1 of living to old age. If you're HIV positive, the probability you live to old age is PHIV, which is less than P. So that's the cost of unsafe sex, is it may reduce your chance of living to old age. Now again, in reality, how long you live is a very continuous variable. It's not a 0 or 1 with old age, but doing everything in a binary way here is just going to simplify all the algebra, and we'll get the same intuition. So sometimes it's useful to do that. why do people want to live to old age? Well, they value being alive. And we're not going to talk about why that is, but there's some value V of being alive. You want to live to old age. That's going to be the assumption. But there's also some value of unsafe sex. Maybe it's easier. You don't have to think about it. You don't have to pay the money for a condom. Maybe it's more fun. Whatever. All those things are in S. This is the value of unsafe sex. Any questions on the setup so far? Now let's make a further assumption, which I think some of the plots that I showed you before would justify, which is when people become sexually active, maybe in their teens or late teens, whatever it is, they start out HIV negative. And again, there are some children born HIV positive, but especially in the era before ARVs, they rarely live to become sexually active themselves. So just assume people are starting HIV negative. So basically, here, the way we're going to model is if you do not engage in unsafe sex in this model, and we're going to talk about a bunch of extensions, but in the simplest form of the model, you're going to stay HIV negative. And you're going to live to old age with probability P. But if you engage in unsafe sex, there's going to be some risk you convert to being HIV positive, and that's going to affect your lifespan. That's the trade-off people are facing in this model. So let's write down the expected utility expression. So, economists to model human decision making model things, as you know, in terms of utility. What is the sort of benefit to me of my actions? And it encompasses a whole range of different benefits. And expected utility is the way we compute utility when there's uncertainty. And here there's uncertainty because there's some probability I'm going to live to old age, but I don't know for sure if I'm going to live to old age. So we're going to think of things in terms of expected utility. If I only have safe sex, what is my utility function? Well, there's going to be two periods here, youth and old age. We're not actually going to talk about time discounting here. We're just going to assume you value both periods of your life equally. For simplicity, we could add time discounting. It wouldn't change anything. I know I'm alive in my youth. Everybody's going to be alive in their youth. They get value V. The probability I live to old age and I get to enjoy my old age is P times V. And then with probability 1 minus P, I don't live to old age, and we're going to call that utility 0. And again, we can call that anything less than V. Doesn't matter, but it has to be less than V, and 0 is simple because it makes the algebra easier. So my utility from engaging in safe sex is V times 1 plus P. Everybody following along the algebra there? Okay, so that's period T equals 1 and then period T equals 2. And then for simplicity now, we can weaken this in different ways later. Assume unsafe sex always leads people to be HIV positive. For simplicity, and again, all we need is there to be a greater risk of becoming HIV positive to get the effect, but this makes it simpler. So now in period 1, I get my utility of being alive and any benefits to unsafe sex, like I don't have to pay for condoms, whatever it is, plus the probability I live to old age now that I'm HIV positive times V, plus 1 minus PHIV times 0. Everybody following along? Okay, so the key issue here is going to be the benefits of unsafe sex are S, and the cost is the difference between P and PHIV. And you're going to be trading these things off. Okay, so this is your expected utility from unsafe sex, that expression there. And you can easily see I'm going to choose to engage in unsafe sex if this condition holds, just doing the algebra. If the benefits of unsafe sex are large enough, and if this gap is sufficiently small, right? If P and PHIV are the same, everybody would have unsafe sex in this model because it's not costly anymore. I live the same amount, and that's the only cost we're modeling to becoming HIV positive. Everybody would have unsafe sex if there were no risk of HIV in this model. But the bigger this gap, and the more I value life, we just assume everybody values a lot, but then you'll be more likely to have, well, actually, the bigger this gap, then this thing becomes really negative, right? So if this gap gets really big, the second term becomes negative, and you're going to be less likely to have unsafe sex. Let me pause for a second. Any questions on the kind of algebra or the setup of this simple model? Okay, so benefits, costs, you trade them off, and that determines the decision. Okay, let's ask a question, and we're going to actually go through in a couple slides and actually try to work out in the model what the case is here. In this framework, if you have better information about your own HIV status, and this is going to require you to think a little bit outside the box, so let me do this in 2 steps. Step 1, imagine I'm making a decision, and I should have set this up a little better. Let me set this up a little bit. Let's say there's 3 periods. Youth, young adulthood, old age. Let's say you've engaged in some sort of sexual practices in your youth, T equals 1. Now you're in T equals 2, and you're trying to decide whether to engage in unsafe sex again. Other than that, the model's the same. Now you have 2 points in time. And in T equals 2, you don't know your status. You don't know if you got infected in T equals 1. Will my giving you that information about your status, whether you're HIV positive or HIV negative, make you more or less likely to engage in unsafe sex? So there's a little bit of build up there. And that's how we're going to kind of model it later on. So I apologize for not setting it up. Again, T equals 1 is just like before. I'm HIV negative, I either have safe sex or unsafe sex. Now T equals 2, I'm trying to decide whether to have safe or unsafe sex again. If I give you better information, are you going to be riskier or less risky? This is a very relevant policy intervention because over the last decade, there's been a huge push to have voluntary counseling centers in sub-Saharan Africa to try to inform people about their status. So theoretically, is that going to reduce or increase people's risky behavior? And then there's T equals 3. I can't answer the quicker question. Go ahead. What's it?
Is this only based on the model or based on what we know about all this stuff? Because
Let's think about the model in this very narrow way I've pitched it with the trade-off that I've presented to you. And then in 10 slides, we're going to talk about the 3 or 4 things that we would want to add to improve this model. But let's just keep in this very narrow cost-benefit framework for now. Okay, let's just take another maybe 10 or 15 seconds. Okay, so there's a real spread here, and I think this is really interesting. Can someone who answered A raise their hand and explain the point about A? Yeah.
So if we're using in the general framework, there's no discount rate, there's no consideration of the person. The people who do not have unsafe sex, that if people who find it negative, there's some possibility that they're going to use safe sex or not. But the people who are already infected, just they're infected, they have nothing to gain from having safe sex. So therefore, in this framework of this model, they would do it.
Right, so that's one of the intuitions.